There's a machine dying in the darkness, nearly 16 billion miles from Earth, farther than anything humans have ever sent. It's alone, colder than you can imagine. Its transmitter runs on about 22 watts, the same power as a refrigerator light bulb. And it's still trying to send a signal home. A radio signal takes almost 24 hours to reach Earth. A whisper from the edge of the solar system, telling us it's still there, still moving, still alive. But it's dying. One by one, its instruments are shutting down. Its power is fading. Sometime in the 2030s, the signal will stop. And it will drift into the void, silent, forever. We launched it in 1977, sent it past Jupiter, past Saturn, past the edge of everything we knew. Tonight, we're following Voyager 1, the loneliest object in the universe, the farthest messenger humanity has ever sent, and the last signal it will ever send from the edge of home. Let's begin. In 1977, something rare was happening. The outer planets, Jupiter, Saturn, Uranus, Neptune, were aligning in a configuration that occurs about every 175 years. A spacecraft launched at the right moment could visit all 4 worlds, using each planet's gravity to slingshot to the next. The opportunity wouldn't come again in our lifetimes. We built 2 machines, Voyager 1 and Voyager 2, each one the size of a small car, packed with cameras, instruments, transmitters, everything we could fit to study the outer solar system. The mission was supposed to last 5 years, maybe 10, if we were lucky. That was the design life. That's what the engineers planned for. Get to Jupiter, get to Saturn, send back data, and then probably fail. Components would break down, systems would freeze, the spacecraft would go silent. But we did something else too. We bolted a golden record to the side of each spacecraft. Not a scientific instrument, a message, encoded with sounds from Earth. Music, greetings in 55 languages, images of human life, diagrams showing where we are in the galaxy. Just in case. Just in case, thousands of years from now, Voyager drifted close enough to another star for something to find it. We knew the odds, but we sent it anyway. A bottle thrown into an ocean we couldn't even see across. Bolted to its side, protected by an aluminium jacket, is the most ambitious message ever sent. The golden record. A 12-inch gold-plated copper disc carrying the sights and sounds of a planet that is now billions of miles away. If you could play it out there, in the silence, you'd hear a mother and child. You'd hear the rhythmic pounding of a blacksmith's hammer, a kiss, a heartbeat. You'd hear Chuck Berry. You'd hear the complex, haunting sounds of humpback whales. You'd even hear the brainwaves of a woman who had just fallen in love, her thoughts compressed into a minute of audio, destined to drift for 1 billion years. It is a love letter to Earth. But out there, the record is silent. There is no one to hear the greetings in 55 languages, no one to listen to the Bulgarian folk music or the Navajo night chants. It's a time capsule whose owners are long gone, carrying a message in a bottle through a cosmic ocean that may never have a shore. Long after our cities have crumbled and our oceans have dried, this gold-plated disk will still be out there, proving that once, for a brief moment in the darkness, we were here. Voyager 1 launched on September 5th, 1977. It left Earth at 38,000 miles per hour, fast enough to escape the sun's gravity forever. The people who built it, engineers, scientists, technicians, hoped it would last long enough to reach Saturn, that it would survive the radiation near Jupiter, that its systems wouldn't freeze in the cold, that its computers wouldn't fail. 5 years, maybe 10. That was the plan. It's been 48 years, and it's still out there, still moving, still transmitting, still alive, long past its designed lifetime, long past what anyone expected, and still going. In March 1979, Voyager 1 reached Jupiter. It flew within 174,000 miles of the cloud tops, close enough to see details no telescope on Earth had ever resolved. The Great Red Spot, a storm larger than Earth, churning in Jupiter's atmosphere, lightning strikes in the darkness, auroras at the poles, and the moons. Io, covered in active volcanoes, the first time humanity had ever witnessed volcanic eruptions on another world. Europa, a smooth ball of ice hiding an ocean beneath. Ganymede, Callisto, worlds within worlds. Voyager sent back images, thousands of them, each one taking minutes to reach Earth, each one showing us something we'd never seen before. Then it left Jupiter behind, used the planet's gravity to accelerate, and aimed for Saturn. In November 1980, it arrived. The rings, up close for the first time, thousands of them, braided, kinked, shepherded by tiny moons we didn't know existed. It passed within 4,000 miles of Titan, Saturn's largest moon, a world with an atmosphere thicker than Earth's, clouds of methane, lakes of liquid hydrocarbons. And then Voyager 1's primary mission ended. It had done what we asked, visited 2 giant planets, sent back data that would take years to analyze, shown us the outer solar system in detail for the first time. But it didn't stop. Its trajectory, bent by Saturn's gravity, was now aimed upward, out of the plane of the solar system, away from the planets, toward interstellar space. We could have shut it down, turned off the instruments, let it coast in silence. But we didn't. We kept listening. And in 1990, 13 years after launch, we gave Voyager one final task. Turn around, look back, and take a picture of Earth. From 3.7 billion miles away, Voyager pointed its camera toward home. And there it was. A pale blue dot, less than a single pixel, barely visible against the scattered sunlight. Every human who ever lived, every war, every empire, every love, every loss, all of it contained in that tiny speck of light. Carl Sagan, one of the scientists who helped design Voyager's mission, wrote about that image. Look again at that dot. That's here. That's home. That's us. And after that photograph, Voyager 1 turned its cameras off. Forever. There was nothing left to photograph. Only the darkness ahead. In August 2012, Voyager 1 crossed a boundary. The heliopause, the edge of the sun's influence, the point where the solar wind meets the interstellar medium. For the first time, a human-made object entered interstellar space. And it kept going. Voyager 1 is now nearly 16 billion miles from Earth, nearly 6 times farther than Neptune, and still moving. 38,000 miles per hour, every second, 17 kilometers farther from home. Beyond the bubble, beyond the wind, in the space between stars, alone. Where Voyager is now, there is no day, no night, just darkness. The sun, the star that has lit every human moment in history, is a distant point of light. Still the brightest point in the sky, brighter than any star, but too weak to warm anything. At nearly 16 billion miles from the sun, sunlight is about 1/30,000th as bright as it is on Earth. If you were standing on Voyager, if you could somehow be out there, the sun would look like a very bright star. Nothing more. And the temperature? Around minus 250 degrees Celsius. Only a few tens of degrees above absolute zero. Voyager's exterior is frozen. Its metal skin, its antennas, the golden record bolted to its side. Frozen solid for decades. Inside, small heaters struggle to keep the electronics warm enough to function. But those heaters are failing. One by one, they're being shut off to save power. The spacecraft is getting colder. And there's nothing out there. No planets, no asteroids, no dust thick enough to see. Just void. The density of interstellar space is about 1 atom per cubic centimeter. Voyager is moving through a vacuum so complete that even at 38,000 miles per hour, it could travel for thousands of years without encountering anything solid. And it's bombarded. Cosmic rays, high-energy particles from exploded stars, from distant galaxies, streak through Voyager constantly. They tear through its circuits, flip bits in its memory, corrupt data. Voyager's computers have error correction systems to catch these flips and fix them, but over time, the damage accumulates. And Voyager keeps moving through the darkness. Every hour, 61,000 kilometers. Every day, 1.4 million kilometers. And there's no sound. In space, there's no air to carry vibrations, no medium for sound to travel through. If Voyager's thrusters fired, tiny bursts to adjust its orientation, there would be no noise. Just a silent puff of gas into the void. If a micrometeorite struck the spacecraft, a grain of dust hitting at interstellar speed, there would be no crack, no impact sound, just silence. Voyager moves through a darkness and a silence more absolute than any human has ever experienced, more alone than any shipwreck, more isolated than any castaway. Millions of miles from anything solid. And somehow, we can still hear it. Every day, Voyager 1 transmits. A radio signal, faint, weaker than the energy of a single snowflake hitting the ground. It travels at the speed of light, almost 24 hours to reach Earth. And we're listening. NASA's Deep Space Network, a collection of massive radio dishes in California, Spain, and Australia, tracks Voyager 1 constantly. These dishes are enormous, 70 meters across, the size of a sports field. And even with dishes that large, Voyager's signal is barely detectable. By the time it reaches Earth, the power striking our antennas is about 10 to the minus 16 watts, 1 part in 10 quadrillion. Voyager's transmitter uses 22 to 23 watts to send its signal, about the power of a refrigerator light bulb. But it's enough, just barely. The signal carries data, temperature readings, particle counts, magnetic field measurements, information about the environment Voyager is passing through, and a heartbeat. Every signal includes telemetry, data about Voyager itself, its orientation, its power levels, which instruments are still working, whether it's still alive. When we receive that signal, we know Voyager was alive almost 24 hours ago. And then we wait for the next one. But the signal is getting weaker. In November 2023, Voyager 1 started to lose its mind. For 46 years, it had spoken to us in a clear, digital language. But suddenly, the stream of data became unreadable. The binary code, the zeros and ones that told us how Voyager was breathing, how it was feeling, stopped making sense. NASA engineers described it as if the spacecraft's voice had been replaced by a monotonous, unchanging dial tone. It was still there. It was still listening. But it couldn't tell us how it was doing. 15 billion miles away, a single chip in its flight data system had failed. A tiny piece of hardware, designed in the early 70s, finally gave way. Maybe to a high-energy particle from space. Maybe simply to age. Think about the challenge. To fix it, engineers at JPL had to go back to paper schematics, yellowed at the corners, signed in 1974. They had to write a software fix for a computer with less memory than a modern car key. And every time they sent a command, they had to wait. They would send the code and then sit in silence for 23 hours while it traveled to the edge of the solar system. Then, they had to wait another 23 hours to see if Voyager had understood. For 5 months, we didn't know if we'd ever hear its voice again. We fixed it. We moved the software to a new part of its aging memory and brought it back to life. But the glitch was a warning. The mind is still there, but the body is wearing out. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs. They convert heat from decaying plutonium-238 into electricity. When Voyager launched in 1977, the RTGs produced about 470 watts of power, enough to run several household light bulbs. Now, 48 years later, they produce about 220 watts, and they lose about 4 watts per year. By 2030, just a few years from now, Voyager will be down to around 200 watts. That's not enough to power all of its systems. So NASA has been making choices. Heaters and systems have been turned off one by one to save power. And in February 2025, NASA shut down Voyager 1's cosmic ray instrument, not because it broke, but to keep the mission alive longer. One by one, Voyager's systems are being shut down because there isn't enough power to keep them on. The cameras were turned off in 1990, after the pale blue dot. The plasma science instrument was turned off in 2007. The planetary radio astronomy instrument was turned off in 2008. And more will follow. Engineers think they can keep at least one instrument alive into the 2030s, and we may remain within reach until about 2036. But eventually, the signal will stop. It won't be because Voyager crashed or because something went wrong, just because it ran out of power. And when that happens, Voyager will go silent. It will still be out there, still moving, still drifting through interstellar space at 38,000 miles per hour. But we won't hear from it anymore. The last signal will arrive, and then nothing. After Voyager goes silent, it will keep moving. For tens of thousands of years, hundreds of thousands, millions. In about 40,000 years, Voyager 1 will pass within 1.6 light years of a star called Gliese 445. Not close enough to be captured by its gravity, just drifting past. Silent, cold, dead. During those 40,000 years, almost nothing will change for Voyager. It won't meaningfully slow down or speed up. It will drift at roughly the same cruising speed, about 38,000 miles per hour, through a void so empty that collisions are rare. No course corrections, no adjustments, no signals home. Just motion. Endless, unchanging motion. The spacecraft itself will degrade slowly. Over millennia, grains of dust can strike the hull. Tiny impacts, imperceptible damage. Over time, the surface may be pitted and scarred. Cosmic radiation will continue to bombard the electronics. Components that failed decades ago will remain failed. Systems that shut down to conserve power will stay dark. The golden record will endure, protected, largely unchanged for a very long time. But everything else will slowly, incrementally deteriorate. And no one will know. No one will track its position. No one will calculate its trajectory. No one will wonder where it is or what it's doing. It will be forgotten. By then, Earth will be unrecognizable. 40,000 years from now, human civilization might be gone, transformed, spread across the stars, or extinct. The ice ages will have come and gone. Continents will have shifted, inched by kilometers. Coastlines may have changed. Species will have evolved and disappeared. And Voyager will still be out there, alone. The golden record will still be intact, bolted to the side of the spacecraft, protected by its aluminium cover. The images, the sounds, the greetings. A message from a world that may no longer exist. And it will keep going. Voyager will drift for millions of years, for epochs we can barely imagine, drifting through the galaxy in silence. It will pass other stars, distant, unreachable, unaware of the tiny machine drifting through their gravity wells, long after every star we can see tonight has died or drifted away. Voyager will still be there. A ghost. A relic. A monument to a species that once looked up and wondered what was out there, and built something to find out. Right now, Voyager 1 is still out there, still moving, still transmitting. Every day, a signal arrives at Earth, faint, fragile, but there. And every time we receive it, we know Voyager is still alive. But that signal is weaker every year. One day, maybe in 2036, maybe sooner, the signal will stop. We'll wait almost 24 hours for the next transmission, and it won't come. You'll wait another day, another week, nothing. And we'll know that Voyager has sent its last message. The farthest human object in existence, finally silent, drifting into the void, alone, forever. We built it to explore, to discover, to reach beyond the edge of what we knew. And it did. It showed us Jupiter's volcanoes and Saturn's rings. It crossed the heliopause. It sent back the pale blue dot. It became the first human-made object to enter interstellar space. And when its power finally runs out, it will drift in silence for millions of years. A messenger from a distant world, carrying a message to anyone who might find it. Someday, somewhere, in the darkness between the stars.